Hello NEET aspirants. So I hope you all are doing great and I hope you all are fine. So alright then, I'm back with you, myself Madhu Yadav. I'm working at Sri Chaitanya Gosala and I'm a senior faculty for zoology. So now in my last session, I have talked about the structure of kidney and the structure of nephron. I have given you every detail of the kidney and nephron. If you have not watched that video, please go back and watch that at this channel only. And in today's session, I will be talking about the urine formation, which is a very important topic, and you cannot understand without understanding the structure of kidney and the structure of nephron, right? So in the structure of nephron, there will be some parts and you need to understand those parts to understand this topic, urine formation. So without any delay, let's get started and let's see the urine formation. It is a very interesting topic and important topic. So you need to understand this very well for the NEET point of view, right? So let's get started. So urine formation occurs in 3 steps. As you can see, the 3 steps, one is the filtration, that is also known as ultrafiltration, right? Or it can be called as glomerular filtration. I will tell you why it is known as glomerular filtration. Then the second step is reabsorption and the third step is secretion. We will talk about each and every step one by one. So let us talk about the glomerular filtration first of all. The glomerular filtration occurs where the first part, glomerulus, and glomerulus is present in the Bowman's capsule. So here I have made Bowman's capsule. This is Bowman's capsule, beta. This is Bowman's capsule, which is the part of renal tubule. I have described you nephron in the previous session. Nephron has 2 parts. One is the glomerulus. Another is the renal tubule. In the renal tubule, I have described Bowman's capsule, proximal convoluted tubule, PCT, then loop of Henle, and then DCT, distal convoluted tubule, which opens into the collecting duct. Many DCTs will open into the collecting duct. I have explained you all this. So now you can understand here in the Bowman's capsule, one afferent arteriole will come. Afferent arteriole will have a greater diameter and here it will make the tuft of capillaries, and then this is the efferent arteriole. So what is this? This is afferent arteriole. You have understood in the structure of nephron. This is efferent arteriole and here this is glomerulus. This is the tuft of capillaries which is known as glomerulus, right? This is what? This is glomerulus. Glomerulus plus Bowman's capsule is known as Malpighian body or renal corpuscle. That also you have seen in the previous session. So this first step, glomerular filtration or ultrafiltration, will occur here. Here it will occur. How it will occur? The blood which is coming into the Bowman's capsule, it will get filtered. So that is why here there is a filtration membrane. Let us understand the filtration membrane first. This glomerulus will have, obviously blood capillaries are there, na? Glomerulus is what? Blood capillaries. So there is a endothelium. There is the simple squamous epithelium of the blood capillary. Then obviously epithelium lies on the basement membrane. So here there will be a basement substance. And then if we talk about this Bowman's capsule, it also has the simple squamous epithelium. Now they will get modified and they are now known as podocytes. These cells are now known as podocytes, beta. Why they are known as podocytes? Because they have foot-like appendages. They have foot-like structure, foot-like appendages. These cells are known as podocytes. They are nothing but they are modified simple squamous epithelial cells. Modified simple squamous epithelial cells. They are now modified for filtration. Now they are modified for filtration or specified for filtration. So there are three membranes here. First of all, the glomerulus will have the endothelium. So let me make the endothelium here. Let us suppose this is endothelium. So in between the endothelial cells, there is a space, right? And then what is there? There is a basement membrane. Let us suppose this is the basement membrane. Do you know that basement membrane is present in below every epithelium? Epithelial tissue can never be present without basement membrane, right? So always below an epithelium, basement membrane will be there. Basement membrane is there below every epithelium. So this is endothelium, this is basement membrane, and then I have told you the podocytes. These are the podocytes. Let me make them like this. Podocytes, foot-like appendages. So these are podocytes, right? So there is a space between the podocytes known as, here we will call it slit pore, and here we will call it fenestra. This is fenestra, right? So what is present here? In the blood capillaries, what is present? Blood is present, right? Here what is present? Blood is present. So here what is there? Blood is present in the glomerulus. What is this? This is glomerulus. Then blood will be passed like this. Blood will be passed like this. It will be filtered like this, right? From the fenestra and slit pores, blood will be filtered like this, and then it will be called as glomerular, because this blood is known as glomerulus. This filtrate will be called as glomerular filtrate. This filtrate will be called as glomerular filtrate. GF, glomerular filtrate it is, right? It can also be called as protein-less plasma. I will tell you why it is known as protein-less plasma. It is also known as, glomerular filtrate is also known as protein-less plasma. See everyone. The blood which is present here, in that blood what is present? Do you know? Blood has two parts. Blood has two parts, plasma and formed elements. Plasma and formed elements. Formed elements are RBCs, WBCs and platelets. So obviously these things will not be filtered. Only plasma will be filtered. That means here from this blood, actually filtration is done for the plasma. So here plasma. And in the plasma, proteins are also present, na? In the plasma, proteins are present. These proteins will also not be filtered. They will stay here only. So that is why it is protein-less plasma. Everything else, apart from proteins, everything else will be coming. What else is present? Apart from proteins, what else is present? Gases are present, nutrients are present, right? Hormones are present, blood anticoagulant is present, heparin. So many things are present. So some of the proteins which cannot filter, they will be remaining here only, and that is why the glomerular filtrate is known as protein-less plasma. Are you understanding what is glomerular filtrate? Now I will tell you how it is formed. Why this filtration is occurring? What are the pressures which are favoring this filtration? So, let us understand the process in detail, the ultrafiltration. Let us understand this in detail. But you have understood where it will take place and how it will take place. Where it will take place? It will take place in the Bowman's capsule. What is there in the Bowman's capsule? Glomerulus. What is there in the glomerulus? Blood. Blood will get filtered through three membranes. Three layers, and these three layers are making a filtration membrane. So this is a filtration membrane, beta. This is a filtration membrane. This is a filtration membrane. Filtration membrane is made up of how many layers? Filtration membrane is made up of three layers. This is endothelium. This is endothelium. of blood capillaries. This is basement substance or basement membrane, and this is the simple squamous epithelium of Bowman's capsule. In the last session also I have told you Bowman's capsule is lined by simple squamous epithelium. Now these simple squamous epithelial cells have got modified for the filtration. So now they are known as podocytes. The cells are known as podocytes because they have foot-like appendages. Right? So this is the simple squamous epithelium of Bowman's capsule. This is the simple squamous epithelium of blood vessel, and this is the basement membrane. These three layers are making the filtration membrane. Question is asked, how many layers are there in the filtration membrane? 3. Question is asked, how many layers are cellular and how many layers are non-cellular? So you can see in the 2 layers cells are present, and in basement membrane there is no cell. It is a non-cellular membrane. So filtration membrane is made up of 3 layers, 2 cellular, 1 non-cellular. 2 cellular and 1 non-cellular. Are you understanding? Alright. So now you have understood, from the afferent arteriole, blood will come, make the glomerular capillaries or glomerulus. Then efferent arteriole, blood will go out. Whatever blood will remain here, that will exert the pressure for the filtration, and that's how the filtration will happen, and from the blood the glomerular filtrate will be formed. Are you understanding this filtration? Now there are 3 pressures which are involved in this filtration. So let us talk about the pressures. Pressures involved in ultrafiltration. Ultrafiltration means this filtration is occurring under pressure. Right? Do you know how to make a tea? It is very simple, and you all should know how to make a tea because it is a basic requirement, right? Right? It is a basic requirement. So, do you know how to make a tea? In today's session, I will also teach you how to make a tea. You have to add water, then tea leaves, then whatever flavor you want, ginger, cardamom, long, anything, whatever you want to have, you can add it in that, right? Then it will boil, right? Again, you will add milk, then boil. In the last, you can add sugar if you want sugar in your tea. If you don't want, you can skip sugar, and here is your tea ready, right? So, what are the components which you have taken in the tea? They are present in the tea. Now, you have to strain it through a strainer. So, whatever cannot go out of a strainer will remain into the strainer, right? Just keep that in mind, and now you will understand all the pressures involved in the ultrafiltration. When you have a cup and you will strain the tea will exert some pressure, na? Whatever tea is coming into the strainer, that will exert a pressure for the filtration, and that pressure here is equal to the GHP. The first pressure, glomerular hydrostatic pressure. Glomerular hydrostatic pressure. Glomerular hydrostatic pressure. What is this pressure? This is Bowman's capsule. This is glomerulus. So the glomerulus is exerting a pressure. And why it is exerting a pressure? Afferent arteriole diameter more, efferent arteriole diameter less. More blood is coming, less blood is going. So blood is remaining there. That blood is exerting a pressure, that is GHP. Glomerular hydrostatic pressure. So it will favor the filtration or it will oppose the filtration? Tell me. It will favor the filtration. It favors the filtration. It favors filtration. It favors filtration. So that is why we will represent it by a plus sign, right? This plus sign is for the favoring. It is favoring the filtration. It is plus 60 mm of Hg. This is your GHP. Just like you are straining the tea, you are filtering the tea. So tea will exert the pressure so that it will come into the cup, right? Now in your tea, you have some ginger or tea leaves which you have added. They cannot come out. So initially the tea will go into the cup faster, but then once the tea leaves and ginger will accumulate in the strainer, less tea will come out. That means whatever things are there in the strainer, they are exerting a pressure opposite to filtration. Similarly, glomerulus is there. Glomerulus is what? Blood. In that blood, plasma. In that plasma, proteins. Those proteins, they cannot filter, na? So they will remain here in the glomerulus only. So they will exert a pressure opposite to the filtration, and that pressure is the second pressure known as blood colloidal osmotic pressure. That is known as BCOP, blood colloidal osmotic pressure. Blood colloidal osmotic pressure. It will not favor the filtration, it will oppose the filtration. It opposes the filtration. This pressure is exerted by the proteins in the blood. The GHP is the glomerular hydrostatic pressure. It is exerted by glomerulus. Present in the Bowman's capsule. Whereas BCOP, this pressure is exerted by proteins. Which cannot filter, right? So this is minus 30 mm of Hg. Minus 30 mm of Hg. Why minus? Because it opposes filtration. Just like when you are filtering the tea leaves and ginger, it will oppose the filtration. Now when it will stuck in the strainer, it will oppose the filtration. Less tea will come once the tea leaves will be accumulated. I hope you are understanding with this example. Now the third pressure. The third pressure is the CHP, capsular hydrostatic pressure. Capsular hydrostatic pressure. Capsular hydrostatic pressure. See, when you are filtering the tea directly into the cup, when the cup is filled with the tea, then no more tea will come into the cup, right? Once the cup is filled, completely filled, then that tea which is present in the cup, that is also exerting a pressure, and that pressure is opposing the filtration, because no more filtration will occur. Once the cup is full, no more filtration will occur. Yes or no? Here also there is a capsule, there is a cup in which the glomerular filtrate is present, right? The glomerular filtrate is present. So that filtrate is exerting a pressure. Here the pressure was exerted by glomerulus, the blood. But here now the pressure is exerted by the glomerular filtrate. Let us look at this. When the filtration will occur, the filtrate will come here now. In this capsular space, there is a space in this Bowman's capsule which is known as capsular space. So the filtrate which will come here, when it will be very much, then no more filtration will occur. The filtrate which is present here, it will oppose the filtration. It will oppose the further filtration. So that is why capsular hydrostatic pressure will also oppose filtration. It opposes filtration. It opposes filtration, and it is how much? It is also minus 20 mm of Hg. Right? This is exerted by glomerular filtrate. So GHP is the first pressure exerted by the glomerulus. It is favoring the filtration. Then BCOP is the pressure exerted by the proteins present in the glomerulus. It is opposing the filtration. Then CHP is the glomerular filtrate which has accumulated in the Bowman's capsule, and it will also oppose the filtration. But still filtration will take place. There are two pressures which are opposing the filtration, but still filtration will take place. Why? Because if you see the values, we can find out the net filtration pressure from here, NFP. The net filtration pressure will be GHP minus these two. BCOP and CHP. So it will be 60 minus 50 mm of Hg. 30 plus 20, 50 mm of Hg. So our net filtration pressure is 10 mm of Hg. Because of this net filtration pressure, filtration is taking place and glomerular filtrate is formed. After the first step, the glomerular filtrate is formed. After the first step, the glomerular filtrate is formed. After the second and third step, the urine will be formed. Alright? After the first step, glomerular filtrate is formed. After second and third step also. So after all these three steps, urine will be formed. I will tell you how urine will be formed. Now let us see how much glomerular filtrate will be formed. 10 mm of Hg. If you can remember this, 1 mm of Hg pressure will lead to formation of 12.5 ml of glomerular filtrate. So by this 10 mm of Hg, 125 ml of glomerular filtrate will be formed in how much time? Per minute. So this is your glomerular filtration rate, GFR. Very, very important to remember. What is glomerular filtration rate? What is glomerular filtration rate? This is 125 ml per minute. Per minute, our kidneys are forming how much ml of glomerular filtrate? 125 ml of glomerular filtrate is formed per minute. So, how much glomerular filtrate is formed in a day? Can you tell me? How much glomerular filtrate is formed in a day? Can you tell me that? So, simply what you have to do, if 125 ml is getting formed in 1 minute, right? So, in a day, you know 24 hours, in an hour, you know how many minutes, right? So, you have to calculate it like that. So, you can simply calculate in a day. In a day, how much glomerular filtrate will be formed? 125 into 24 into 60. That's how you will calculate and you will get 180,000 ml. That means you will get 180 liters. 180 liters glomerular filtrate is formed per day. In a day, our kidneys are making 180 liters of glomerular filtrate. But we are not excreting that much of urine. How much urine we are excreting per day? 1 to 2 liters. 1 to 2 liters. So that means out of 180 liters, if 1 to 2 liters urine is formed per day, that means where all that glomerular filtrate has gone? It has reabsorbed. The second step, reabsorption will take place. So by the reabsorption, 99% of the glomerular filtrate will be going again back to the blood. I will tell you the meaning of reabsorption. So here you need to understand that 180 liters, out of this 180 liters, 1 to 2 liters urine formed per day. Urine forms per day. So that means 99% of glomerular filtrate is reabsorbed. Now I will tell you one interesting thing. Here. What is the filtration fraction? Let us talk about filtration fraction. What is this filtration fraction? See, what is the cardiac output? Do you know the cardiac output? Cardiac output means how much blood pumped by each ventricle per minute. That is the cardiac output. So per minute, 5 liters of blood is pumped by the heart, by the each ventricle. Right? So what is the cardiac output? 5 liters. how much blood which is pumped by the each ventricle, how much blood is going to the kidneys? 1/5 of cardiac output. 1/5 of cardiac output. 1/5 of cardiac output is going to kidneys. Going to kidneys per minute. Per minute. Right, everyone? This is known as renal blood flow. What is renal blood flow? Renal blood flow is 1/5 of cardiac output. That means we can find out 1100 to 1200 ml. Somewhere it is 1100 to 1200 ml. Now from this renal blood flow, from this blood, what is getting filtered? Plasma is getting filtered. So what is renal plasma flow? If you know, in the blood there is 55% plasma and rest is formed elements. 45% is formed elements. So in the blood, if 55% plasma is there, then from renal blood flow, what will be the renal plasma flow? 55% of this. It will be somewhere 700 ml. So this is the renal plasma flow. From this 700 ml, how much filtrate is formed? 125 ml per minute. That is filtration fraction. Filtration fraction is glomerular filtrate formed per minute divided by renal plasma flow per minute. This is equal to 125 ml upon 700 ml. So it will be nearly equal to 18 point something and we will take it to 20. So it will be 20%. So if somebody will ask you, what is the filtration fraction? Filtration fraction means how much glomerular filtrate is formed per minute divided by how much plasma is coming. Out of total, what is we are getting, right? So total is 700 ml glomerular filtrate per minute, and out of that 700 ml, how much glomerular filtrate is formed? 125 ml is formed. That is the filtration fraction. How much filtration is happening? 20%, right? It will be equivalent to 20%. So you can remember this, right? This is also one important concept. Now, we have understood filtration fraction. We have understood the first step, ultrafiltration, right? We have understood the first step. You have understood what is the glomerular filtration rate. This is the most important step in the urine formation. Next, this is a very good and self-explanatory diagram of NCERT which will tell you the reabsorption and secretion. So we will understand reabsorption and secretion by the help of this diagram. The second step is reabsorption. What is the meaning of reabsorption? Here the arrows which are going out of the nephron, like this arrow which is going out, this is simply showing you reabsorption. This arrow going out of the nephron, from nephron to blood. What is the meaning of reabsorption? If something is going from nephron to blood, it is coming out of nephron, is known as reabsorption. Why it is known as reabsorption? Why not absorption? When you will eat food, the food will go into your gastrointestinal tract, digestive system. In the digestive system, the food will be digested and then it will be absorbed. Absorbed means from here, the food will go, the nutrients will go into your blood. So when first the nutrients or the minerals or the vitamins, anything from the food, when first it is coming into the blood, it is absorption and it is happening into your small intestine. Then this blood is going to the kidneys for the filtration. After filtration, some of the things will again come into the filtrate. Now, let us suppose the sodium chloride, the water, the nutrients which are important for our body, they have come into the glomerular filtrate. We cannot let them go into the urine. We cannot let them pass out of our body. We need to take them back. So that is reabsorption. Again we are absorbing. right? Again we are absorbing, again we are taking them back into the blood. That is reabsorption. Reabsorption. So absorption is taking place in the small intestine, reabsorption is taking place in the nephron. Maximum reabsorption where it will occur? Maximum reabsorption will occur into the proximal convoluted tubule. Then you can see another arrow. This arrow is also coming out. That means water is coming out. This is descending limb of loop of Henle. It is permeable only to water. So water can come out. This is the reabsorption of water. This is the reabsorption of sodium chloride. Reabsorption of sodium chloride, right? And then this is the reabsorption of again water, the collecting duct. They are showing you the reabsorption of water. Here also it is showing you the reabsorption of sodium chloride and water and bicarbonate ions. But the arrows which are going into, they are telling you the secretion. They are telling you the secretion. That is the third step, secretion. That is the third step. So the arrows which are going into the nephron, let me show these arrows with the, maybe this color. This color will be visible here. So this arrow, these arrows which are going into the nephron. Here reabsorption means coming out of the nephron. But when it is going into the nephron, that is secretion. I hope you are understanding this. So for example, this urea is being secreted here, beta. This urea is being secreted into the ascending limb of loop of Henle, but when it is coming out of the nephron, it is reabsorbed. So here it will be red. This arrow is representing reabsorption. Another arrow is representing secretion. Alright. So now reabsorption will take place at various places. Like reabsorption will occur first into the PCT. Maximum reabsorption of everything. Maximum reabsorption, 70% water, electrolytes, nutrients, 90% of bicarbonate, everything will be reabsorbed here. Maximum reabsorption. Why? Because I have told you in the last session, if you have seen my last session, there I have told you which epithelium is present in the PCT. Brush bordered cuboidal epithelium is present in the PCT. So if brush bordered cuboidal epithelium, more surface area, more reabsorption. Maximum reabsorption PCT. Loop of Henle, minimum reabsorption. Loop of Henle, minimum reabsorption. Two parts of the loop of Henle, descending limb and ascending limb. Loop of Henle shows minimum reabsorption, right? Descending limb, the reabsorption of water will take place, only water, because it is permeable for only water. Ascending limb, only sodium chloride, salt, only salt. It is permeable for only salt, right? So minimum reabsorption. Then you can see there are two segments in the ascending limb. One is the thick segment and one is the thin segment. You can remember from the thin segment, easily the sodium chloride can be reabsorbed. That means it can be reabsorbed passively. But from the thick segment, it will be reabsorbed actively. Active means energy is utilized. So from the thin segment, this reabsorption is taking place passively. Whereas from the thick segment, it is taking place actively. Active reabsorption, here passive reabsorption. Always remember, urea is being reabsorbed from the collecting duct. That is also passive reabsorption. Alright. So, you have seen where the active reabsorption will take place, where the passive reabsorption take place. Always remember, when urea is getting reabsorbed, it is reabsorbed passively. Urea shows passive reabsorption. Passive means energy is not utilized, right? Now, so this is all about reabsorption. You have seen the reabsorption in PCT, loop of Henle, then in DCT also. You can see rest of the water and salt will be reabsorbed. Always remember one thing, always remember one thing, that in DCT and collecting duct, they are collectively known as distal parts. Distal parts. They are collectively known as distal parts of the nephron. Distal parts means they are the parts which are coming at the end. First DCT and then collecting duct. Distal parts of convoluted tubule. Here conditional reabsorption will occur. Conditional reabsorption means under some conditions. Under some conditions, like there are two conditions. One is aldosterone. Another is ADH. Aldosterone is a hormone secreted from the adrenal gland which is present above the kidney, I have told you. Right? And ADH is anti-diuretic hormone or vasopressin. It is a hypothalamic hormone. It is produced by the hypothalamus. Right? You will understand about these two hormones in the chemical coordination and integration chapter. But here, just remember these two hormones. Aldosterone, when act on the DCT and collecting duct, then sodium chloride will be absorbed. And when ADH, anti-diuretic hormone, will act on the DCT and collecting duct, then water will be reabsorbed. So here you can see water, right? Here also you can see water is being reabsorbed. It is coming out of the nephron, reabsorbed. So always remember, distal parts, DCT and CD, they show conditional reabsorption. Conditional reabsorption. Under which condition? Under aldosterone and ADH. Under influence of ADH and aldosterone. ADH is also known as vasopressin. Due to aldosterone, sodium chloride will be reabsorbed. Due to ADH, water will be reabsorbed. That is why it is known as anti-diuretic hormone. Anti-diuretic hormone means it will prevent the water loss. It will prevent diuresis. It will absorb all the water. When all the water will be absorbed, then in the urine there will be less water loss. It will prevent water loss. Based upon this, questions are being asked. Right. So this is all about reabsorption. Then you can understand secretion. After reabsorption and after secretion, only urine will be formed. So what is in the secretion? You can see here, whatever is more in your blood to maintain the ionic balance and the pH of blood, the secretion is occurring. What is the purpose of secretion? The purpose of secretion is to maintain the ionic balance and pH. To maintain ionic balance and pH. Right? So, whenever some ions are more into the blood, they will be secreted into the nephron so that they will go out of the body. Right? Like ammonium ions you can see here, hydrogen ions you can see here, they are going into the PCT. Yes or no? They are being secreted into the PCT. Excess of hydrogen ions should not be there in our blood. Right? That is why when excess of hydrogen ions are there, they will be secreted into the nephron so that they will go out along with the urine. Same with the ammonia. Then you can see what is being secreted into the loop of Henle. So, according to the diagram, you can see what is being secreted into the PCT. According to the diagram, what is being secreted into the loop of Henle, what is being secreted into the DCT, and what is being secreted into the, so nothing is being secreted into the collecting duct, right? So now, simply you have to understand about PCT and loop of Henle. In the PCT you can see, and then DCT. In the PCT you can see H plus ions are being secreted and ammonia is being secreted. Then into the loop of Henle you can see urea is being secreted. Yes, urea. And then you can see in the DCT, this is the DCT here, potassium ions are being secreted and again hydrogen ions are being secreted. Right? So, depending upon the ionic concentration in the blood, whether it is potassium ion, whether it is ammonium ion, whether it is hydrogen ion, they will be secreted into the nephron. Right? After the reabsorption is done and secretion is done, there will be urine formation. So, after ultrafiltration or glomerular filtration, after ultrafiltration, then reabsorption and secretion. Ultrafiltration, reabsorption and secretion, what is formed? Urine is formed. After only ultrafiltration, what is formed? Glomerular filtrate is formed. This glomerular filtrate is present in the nephron. Few things will be reabsorbed from it. So, will be going out of the glomerular filtrate, will be going out of the nephron, and few things will be coming into the nephron. When the things are coming into the nephron, that is secretion. When the things are moving out of the nephron, that is reabsorption. This is a self-explanatory diagram. You need to understand this, and this is all about urine formation. So, I hope you have understood ultrafiltration, reabsorption and secretion. These are the basic terms. If you will understand the meaning, then you will understand the concept. Ultrafiltration, where filtration is occurring. The blood is coming into the kidneys. In that blood, what is being filtered? Plasma is being filtered. Then what is getting formed? Glomerular filtrate is formed. How much is formed? 125 ml per minute is formed. That is your glomerular filtration rate. Then, out of this glomerular filtrate, few things are absorbed, reabsorbed. That is reabsorption, because we can't let the nutrients go into the urine. We can't let the minerals go into the urine. We can't let the salt and water go into the urine out of our body. So, we need to take it back. So, when we are taking it back into the blood, then it is known as reabsorption. And when few things are more in our blood, when the concentration of some ions are more in our blood, to maintain that ionic balance and to maintain the pH of our blood, we are secreting few things into the glomerular filtrate. So, once the ultrafiltration is done, reabsorption is done, secretion is done, urine is formed. Right, everyone? So, I hope you have understood all this, all the steps. Right? So, let us continue this topic. Few more important areas are there, and I am going to discuss some important questions, previous year questions which have come from these topics or from this chapter. So, I will be taking up that in the next session. So, stay tuned for the next session, and all the best for your NEET preparation. Thank you.